that I've created here, and it took me about an hour to do using IC3D Steel. Now you can see in here we've got bolted connections, we've also got some web stiffening, we've got base plates and end caps, and all the other bits associated with this sort of bolted structure. And that, like I said, that took me about an hour to do. Now, if I was to be doing that using pre-existing SolidWorks functionality, that would probably taken me the best part of a day. So very quickly you can see here that there is enormous time benefits to be had from using 3D Steel, and it's also very simple to do. So I'm just going to break away from this and show you how we use 3D Steel. Okay. So for those of you who are familiar with SolidWorks, you'll be probably familiar with the existing weldment functionality, which lives in the part environment and is very good for producing welded steel structures, but there's just no functionality in there for producing bolted steel structures. So what I'm going to do here is I'm going to highlight the bolted connections that you can be automated using 3D Steel. So the first thing to note is that we're working at the assembly level. Second thing is that I've just created a very basic sketch. This is going to be a column and this is going to be a beam. So, and now what we're going to do is we're going to start using the 3D Steel toolbar. And this is just an additional toolbar that is installed with 3D Steel. And this sort of highlights the philosophy behind 3D Steel. Rather than creating a piece of software that sits on top of SolidWorks and basically reinvents the software, what we've done with 3D Steel is actually try to integrate it into the software itself. It becomes like an extra palette of tools to help the user create models. So it's added to the pre-existing toolbars, and the first thing I'm going to do is use the Insert New Detail tool. Before I start, you can see here what it does is it breaks out into sections the tools that we can use in here. First of all, we've got the Australian standard, standard profiles. So you can see in here we've got angle, flat bar, PFCs, rolled square bar, all the standard sections for the Australian standard. Currently we are working with the Australian standard, and as we move into requests we'll add the American and other standards as need be. So the first thing I'm going to do is add a column. And in a similar way to SolidWorks, you just pick the line and then a preview comes up, and this shows us the orientation of this column. And there's a tool here where we can reposition it, and we can even offset it. I think you can just see that's been offset by 20 mil. So that's new functionality from 3D Steel. That ability to offset. I'm just going to rotate this around 90 degrees because we're going to have a column, the beam running into it. I'm just going to OK that. And you can, so there's our new column. Now I'm going to add a horizontal beam. This time I'm just going to shortcut it by using our favorites list. And this time, rather than using the line, I'm going to use the points, which is another new feature for 3D Steel. So you can see here it's put in at 90 degrees. I'm just going to rotate that around to 0. And I'm going to decide to offset it. There we go. So that, yep, I'm happy with the orientation. And I'm just going to insert that. So let's step back a bit. You can just see now what's happened here. We're working at the assembly level, so what 3D Steel's done is it's actually created 2 part files. So this is the big difference for 3D Steel, is it's released SolidWorks to work at the assembly level. And we're actually going to be working with parts and sub-assemblies rather than bodies and features. Okay, so this is our basic frame. We now need to add a connection that goes between these 2 items. So I'm going to return to the Insert New Detail tool. And this time I'm going to go and add one of our library of connections that we've got. And you can see here that there are a whole host of connections to add. We can do end caps, base plates, flexible end plate connections. So I'm just going to pick this one to be different. So OK that. And then this works in a similar way to inserting a sub-assembly. So what we do is we drag our connection in. We just position it a bit. And then we provide it with 2 references which explain to us how the connection will understand how to be put in place. So it's asking for a reference for the column, and it's asking for a reference for the beam. So if I just OK them. And then once it's done that, we now get the ability to customize the connection to suit what we want to do. So we can play around with the plate thickness, the bolt sizing, the bolt pitches, the number of bolts involved. I'm going to choose 6, which I know is not going to work. Oh, actually 7, okay. And also we can play around with the gaps and other things. For each connection there's a unique set of options that basically use the guidelines for the AS standard. So if I just press OK now, 3D Steel is now going to go about the process of adding the cuts. Oh, it's done it already. The holes. You can see here. I'm just going to turn the annotations off. So it's adding the holes through the column, and it's set back the beam, and it's done all the preparation work. Now you notice that I actually called up 7 holes, but it said it's identified that actually there's only space for 3, and as a result it's only allowed me to put 3 in. So that in basic principle is the modeling environment. So let's look at something a bit more complicated. There we go. No. There we go. Okay. So this is typically how I would start a job. I would first of all create a wireframe mesh of the structure that I want to create, and this you'd use existing SolidWorks functionality. So there's various tools. There's a grid tool that comes with SolidWorks. Where are we? There's a grid system that you can insert. We can also use 3D sketches, or a combination of 3D sketches and planes. However, whatever you need to do to create the structure you need, there's a whole host of SolidWorks functionality out there. Then the next step would be to actually start inserting the columns and the beams like I showed before. So let's start doing them. And this time I'm going to go a bit quicker and start picking multiple sections. So I'm happy with the orientation of these. I'm just going to insert them. So if we look on the left-hand side, we can see that 3D Steel has created these 4 columns, and it's also grouped them into a folder with the description of the profile. If we now add some beams, I'm just going to I'm not quite happy with the positioning of them, so I'm just going to offset them top of steel. There we go. Insert them. So it's adding those 12 horizontal beams. Now I want to connect and create a beam that goes between this point here and this point here. So let's just pick something a bit different. Let's go 200, and I'm going to go select those 2 points and just insert them. So on top of the ability to use points as references, which is unique to 3D Steel, there's also the ability to use actual pre-existing edges. So for an example, we can create this angle, take this angle flange, and actually use this edge face here to insert it. So if you happen to be doing, for example, angle flanges, we can now just use those pre-existing edges. Previously, you would have to apply a sketch line onto that edge there and then insert the beam, which is like a twofold process, which just it's just time consuming. So there you go, we just inserted that angle onto that web edge there. So I could continue building this up, but very quickly, as I think you can see, we would end up with pretty much this structure here, give or take. Okay, and you can see here that all the beams and columns have been inserted, but that they're all overlapping and they're ready now for the trimming and connections to be added and to suit. So I've showed you a bolted connection. This time I'll show you a welded connection. Let's have a look. We'll go for that one. Just going to drag that in. And you can see here it's asking for a beam, the 2 beam references. So I'm just going to select that one and then that one. And then OK. In here we've got a few less options than before because there's a little bit less to do, but we can play around with the thickness of this plate. So we'll just make that, say, 16. And we can also ask if it's coped for the welding. So there we go. You can see here that 3D Steel has not only cut back this beam, so it's profiled around the main beam, but it's also added a web stiffener in for us. Let's show off some more examples of what we can do. I'm going to insert now some base plates. Okay, so rather than having to insert all the connections in one by one, which could be quite time consuming, we can actually shortcut that by adding multiple connections in at the same time. So base plates is a good example because chances are all these base plates are going to be the same. So I drag and drop them in, pick 2 references. One is for the column, and then the second is for the actual datum for grade. There we go. Like so. Then I press OK. And then it takes us to, there's quite a bit of customization we can do for base plates because obviously there's different types with holes and plate thicknesses, and let's go for 8 holes. And one of the options here is to choose either the corner bolt spacing. So I'm going to go for a 450 corner bolt spacing, and I'm also going to change it so that there'll be a 10mm fillet weld on between the column and the base plate. So that's okay, that. So 3D Steel is now going to go about cutting back those columns, resizing the base plates. What it's also doing in the background is it's checking to make sure that that particular base plate will fit on that column. If, for example, we make the bolting pitch too small, the bolt holes will overlap the column. We don't want that, so it would have automatically resized it so that it stretches out. Goes out to the minimum it would need to be. So there we go. So if we just quickly review the feature tree for this assembly, you can see here we've got the columns grouped together and the beams grouped together, and then you can see here it's applied these are sub-assemblies. And if we expand these out, you can see that these are standard SolidWorks sub-assemblies. There are no special new features in the model once it's been inserted that locks it. Everything that once a connection has been added to 3D Steel, it then becomes a standard SolidWorks model. This means that someone who's working on 3D Steel can then send it over to someone who doesn't have it. They can open it up, edit that model just like they would a normal assembly, and they wouldn't have any problems. What this also means is if that you have a particular connection that you're not happy with, it doesn't fit into the standard library, or you have an oddball that you need to modify, once the connection's been inserted, like I said, it's yours to do as you will. So say we want to make this web stiffener a bit deeper. We're not happy with the default value that 3D Steel has advised. We can change that. Maybe that's not necessarily the most obvious little change. Let's make a bigger change. There we go. You can see that that depth has increased, and that's now been changed. And that applies all through the board. We can go back to the base plates, and we can start changing the dimensions of the base plates. There we go. And update to suit. So using that principle, we can build up our structure assembly, and I would say within the hour you would have what we have here. Like so. So like I said, this took me about an hour to produce. Obviously, there isn't quite time to do it here, but you can see here we've added some web stiffening. We've used actual angle cleat connections, and we've got quite a complicated connection in between here, which is all automated. So producing the model is only really the first step. The most important stage is to actually produce fabrication drawings from that. And there are two ways we can produce fabrication drawings. In 3D Steel, we can either produce like piece-small, one-off fabrication drawings for the individual pieces, like the base plates, and we can also produce general arrangement fabrication drawings for highlighting all the pieces that are welded together. So the first thing I'll show is the piece-small fabrication drawing approach. So the first thing we need to do for that is we're going to use we're going to create a mark numbering scheme. Here's one I produced earlier. You can see here 3D Steel has grouped together all the similar items, and it's given them a mark number 1 through to 20. So let's just quickly recreate that. Okay, so we could either just press the auto numbering tool, and what would happen there is that 3D Steel, like I just showed you a second ago, would group all the similar items together and give them the same mark number. Or we could apply a numbering rule, which is where through a set of rules that may be due to company philosophy or following international standards. For example, the basic one we've got applied here is that for all vertical pieces, it will be given a prefix of C, and for all horizontal pieces, it will be given a prefix of B. So let's just apply that. So press the auto numbering with the numbering rules turned on. 3D Steel is now just working through the model. There we go. And you can see here, for all these beams, it's called them B4, B5. We could probably do a bit more work with this mark numbering scheme because it's also highlighting any horizontal pieces of plate that it thinks it's going to give the B to. It is possible actually to call up base plates with, say, just plate with a prefix of P if need be or something. And if we go through the columns, there we go. C5 is these columns here. So we've now created a mark numbering scheme, and if we just show that, you can see what's actually happened. So it's applied a mark number to that angled cleat called C4, and it says there's 24 of them. Well, that kind of makes sense. I think there are 24 in this assembly. Let's pick something a bit more obvious. There we go. These base plates, there's 4 of them. These end caps, there's 4 of them, and I'm pretty confident that's correct as well. So once we've created the mark numbering scheme, we can then use that to drive the drawing generation scheme. And we're going to basically create a drawing for each of these unique items. There are custom options in here for how we can use company templates, change the sheet size, bill of materials and all that information. And then once we've set that up, we can create individual drawing sheets for these unique items. So we'll end up with one drawing for one of these beams rather than 4 drawings. I think you can see that it's highlighting them in blue. So if I press OK now, it will now run through the drawing generation process, which takes a couple of minutes as it chugs away and produces the 20 or so drawing sheets with all the views. So I'm just going to skip that. And I'm going to just show you an example, a couple of examples of what you receive here. So you can see here, there's the individual sheets, and currently at the moment, let's just open one up. You end up with a drawing sheet with 3 standard views and a bill of materials. And the bill of materials uses the existing SolidWorks functionality, so it's parametric, meaning that if we make changes to the model, the bill of materials will update to suit. This has been modeled in grams, so that's why that's quite so heavy. If that plate was to get bigger, that weight would change, and so would the description. It would probably change maybe to 10 by 190 if need be. So that's how we produce our piece-small fabrication drawings. And the process for creating the composite fabrication, the general arrangement fabrication drawings is very similar. So we'll go back to one I've done earlier. And in this situation, what we've done is we've created these general arrangement mark numbers. So you can see here I've grouped together the items that I want to have with the same mark number. And you can see here, let's go speak with this one. It's the end cap, the column, the web stiffeners, and the base plate. Sorry about that. So, okay that. And there you can go. You can see that these are the mark numbers for these items. and in each case there's one of each. Mark number 10-8, item quantity 1. So same as before, we're now going to use that mark numbering system to drive the drawing scheme. So it's exactly the same process. We can again customize the drawing presentation, and then we can use these to create individual drawing sheets for those drawings. So you can see in the window what's going to be included in the drawing. You also get information down here. Now, I'll just go to there we go. So this is one of the columns that's created out. You get the 3 basic views. So you can see here you get all the holes included that come through, the bolt holes for the angle cleats, as you'd expect, which is consistent with SolidWorks. There's the bolt holes in the flanges, and then in this bill of materials here we can see what went into making this item. So there's 5 items included in here, and once again if we were to change it they would update to suit. So very briefly, I hope that's given you a flavour of the workflow that is used within 3D Steel and how it integrates basically with the existing SolidWorks functionality. So if you're an existing user, the learning curve is very short, and even for new users, because the workflow is very repetitive and simple, it's the grid reference, adding of the actual members, then using the connections, and then applying the mark numbering scheme to drive the drawing creation. The workflow is very straightforward. Has anyone got any questions? Can you define your own joints? Yes, there is we can actually create your own connections. So there is a tool in here where we can define various parameters for a connection. We can create a piece of a plate connection, for example, if you have like an ad hoc situation where you want to bolt some, on a lot of jobs you have just maybe a horrible connection that's a beast which has lots of things going into it. We can create them in here using these tools here where there's a simple workflow for setting them up. Anything else? No? Okay, all right. Well, if you guys have any other questions, please, by all means, I think you've been talking to Jane. Get in contact with her. Obviously, look forward to hopefully speaking to you again. Thank you very much for listening, viewing this presentation.